Our telescopes are constantly scanning the skies. The search for extraterrestrial life has been science's one of the topmost priority. We have spent millions, billions even, to find the slightest clues of life through audio or visual mediums. But all our efforts seem to have gone in vain, until something surprising happened. Back in 1977, while reviewing a recorded data, astronomers discovered a strong narrowband radio signal detected by the Ohio State University's Big Ear radio telescope. The signal appeared to come from the direction of the constellation Sagittarius and bore the expected hallmarks of extraterrestrial origin. Astronomer Jerry R. Ehman, who detected the signal, was so impressed by the result that he circled on the computer printout the reading of the signal's intensity and wrote the comment, "Wow," beside it, leading to the event's widely used name. The entire signal sequence lasted for the full 72-second window, during which Big Ear was able to observe it, but has not been detected since, despite several subsequent attempts. Many hypotheses have been advanced on the origin of the emission, including natural and human-made sources, but none of them adequately explain the signal. The WOW signal remains the strongest candidate for an extraterrestrial radio transmission ever detected. Since then, we have detected countless radio signals coming from several directions. One of them came from the direction of Proxima Centauri, arising hopes in the hearts of several people that an alien civilization from our nearest star was trying to contact us. It turned out that the radio waves were created by human-made technological anomalies. Likewise, many signals detected over the years have a natural explanation. Until now. Mysterious fast radio bursts release as much energy as the sun pours out in a year, and a newly published research has deepened the mystery around them. Using a huge Chinese telescope, the team detected 1863 bursts in 82 hours, over 54 days from an active fast radio burst source, called FRB 2020-1124A. 15 years after the mysterious pulses from deep space were first discovered, the new observations have challenged ideas about what causes the signals. While scientists want to believe that the signals are coming from collapsed stars, science suggests that they might be evidence of something we are not familiar with, something unknown. Yes, extraterrestrial civilizations. The cosmic FRB observations were made in late spring 2021, using the massive 500-meter aperture spherical radio telescope, FAST, in China. For those who are unaware, fast radio bursts are bright pulses of radio emission, mere milliseconds in duration, thought to originate from distant galaxies. Astrophysicist Bing Jiang of the University of Nevada said, "These observations brought us back to the drawing board." What is interesting is that this is the largest sample of FRB data from one single source till date. Recent observations of a fast radio burst from our Milky Way galaxy suggest that it originated from a magnetar, which is a dense city-sized collapsed neutron star enclosed in extreme magnetic fields. These fields are so strong that they turn the vacuum in space into an exotic plasma composed of matter and antimatter. The origin of very distant cosmological fast radio bursts, on the other hand, remains unknown, and the new observations leave scientists questioning what they thought they knew about them. What makes the latest observations surprising to scientists is the irregular short-time variations of the FRB source. A natural cosmic source would have regular variations happening at a regular frequency. In this case, however, the variations went up and down during the first 36 days of observation, and then suddenly stopped during the last 18 days, before the source quenched. Astronomers are puzzled, as this FRB source is in an environment that was never imagined before. Such an environment is not straightforwardly expected for an isolated magnetar. Something else might be in the vicinity of the FRB engine, said Jiang. But here is where astronomers found themselves at crossroads with dilemma. Normally, young magnetas are believed to reside in active star-forming regions of a star-forming galaxy, but the data of the source reveal it is coming from a metal-rich, barred spiral galaxy like our Milky Way. And in this region, there is no significant star-forming activity. So, what could be sending us these radio signals? Scientists aren't ruling out an extraterrestrial contact. It may be that someone is trying to reach out to us. Or maybe, someone sent out signals in space, and after many years, our planet happened to have bumped into it in the ever-marching wagon of space-time. Or maybe there is a natural explanation that we have not yet discovered. Only time will tell. What do you think? Are aliens trying to contact us? Or, it is just a magnetar? If we are not alone in the universe, why is it taking us so long to make the first contact? Maybe, because our ways of looking is primitive. Let me explain how. When Einstein published his general theory of relativity in full mathematical detail, it opened a window on a radically new framework for physics, abolishing established notions of space and time, and replacing Newton's formulation of the laws of gravity. Back then, Newton had a godlike stature in the world of physics and astronomy, and challenging his theories obviously did not go well with the scientific community. And, as you can tell, relativity got a lot of flack in its early days. But the rest, as we know, is history. Since then, we have countless proofs of general relativity. Even the new images from the James Webb Space Telescope shows the bending of space-time around massive celestial objects, and, while doing so, it focuses and magnifies light like a telescope in an effect called gravitational lensing. But hold on. Visible light might not be the only thing that is affected by this process. Researchers now believe that communication signals might also be amplified through gravitational lensing. And if that's possible, we might even be able to eavesdrop on extraterrestrial communications being relayed around the sun. The idea becomes more interesting as we dive deeper into it. The study theorizes that vast interstellar communication networks could use gravitational lensing to relay transmissions over great distances, similar to how cell phone networks operate here on Earth. We use networks to communicate with each other all the time. When we use a cell phone, the electromagnetic waves are transmitted to the nearest cellular tower, which connects to the next tower, and so on and so forth. If probes are set up in specific positions near a star to take advantage of its gravitational lensing, they could be used as relay points for this communications network. And, if an advanced alien species has discovered this process, and they happen to be using the sun as a relay point, we'd be able to pick up those signals. Before you dismiss this idea as outlandish, hear me out. We have started taking baby steps towards making this theory a reality. The researchers have tested this hypothesis by collecting data from the Green Bank Telescope in West Virginia and searching for radio transmissions that might be relayed from our nearest stellar neighbors located in the Alpha Centauri system. There have been a few previous searches using optical wavelengths, but this time they chose to use radio wavelengths because radio is a great way to communicate information across space. The search, which was a test, was limited to one night, so anything that wasn't broadcasting while we observed was not going to get picked up, although our limited search could miss existing probes if they weren't constantly broadcasting at these frequencies. This was a good test to see if this kind of search is possible. And the group hopes that gravitational lensing can also be used beyond the search for alien life. We'd also be able to communicate with our own interstellar probes using the same method. Yes, our cosmic towers. For humanity to become multiplanetary and a spacefaring civilization, we would need methods to communicate back to Earth. The desire to know our place in the universe is a core human yearning, and people have pondered the question for thousands of years. We couldn't move beyond mere speculation for a very long time, however, until we invented telescopes and developed a proper understanding of the scientific method. Humanity notched both of those milestones centuries ago, and science is now going great guns in the search for alien life. But some people, including the late physicist Stephen Hawking, have argued that it's unwise to advertise our presence to aliens, whose nature and intent are complete mysteries to us. These creatures may pillage our planet after picking up our ping after all. But other researchers think any creatures advanced enough to travel to Earth would already know we're here anyway. And we might be of no use to these beings, as they would be way up in the Kardashev scale. We, however, have just begun. And we should not stop. As such, the search for life beyond Earth continues. What do you guys have to say?